Welcome to Production Resources Incorporated Learning Center video series. In this video, we will be programming a green sensor. A green sensor is an event type known as a cyclic event. Cyclic events occur once a stroke at a predictable degree angle of the stroke. This is called the ready signal. The ready signal is when we look for the green sensor activation to occur. To program a green sensor, turn the program run key to the program position so that the main program menu is displayed. Select the Tool Manager soft key on the screen. In our example, we will be adding a green sensor to an existing tool number. To edit an existing tool, select the tool number you are adding the green sensor to. We will be editing tool number 4656A. After selecting it, it should be highlighted in green. Press the Edit Tool soft key on the right side of the screen. The main programming menu will appear, displaying all the available options that are installed on the SmartPAC Pro. You will notice that the SmartPAC Pro is a menu-driven program that will guide you through the programming process page by page. To program the green sensor, select the die protection key. The sensor inputs available to program will appear. This could be 8, 16, or 32 sensors depending on the sensor option that is installed in the SmartPAC Pro. The green sensor we are programming is connected to sensor input 3. We'll select sensor 3 and a list of common sensor names will be displayed. If the sensor application you want to monitor is not listed in the canned list of names, you can create a custom sensor name by selecting the New Entry button located on the right side of the screen. In our example, we will name this green sensor part ejection from the existing list. There are 5 green sensor types to choose from: green, green quick check, green constant, green special, and green flex. The application that is being monitored will determine which type of green sensor should be programmed. Each green type of sensor has specific criteria on how the sensor must activate and when. Our example, we are going to program a green sensor. We now determine how we want the press to stop if a part ejection fault occurs. Emergency stop will generate an immediate stop command once the sensor fault is detected. Top stop will stop at the top of the stroke after the fault is detected. Smart stop is a combination of emergency stop and top stop. As we discussed during our red and yellow sensor programming videos, the critical angle for this tool is 100 degrees. Sensor faults that occur from 100 degrees to 185 degrees of press angle will generate a top stop. Sensor faults that occur from 185 degrees to 99 degrees will generate an emergency stop. If the part being monitored is not ejected properly, we run the risk of crashing the die. We expect the part to be ejected prior to the critical angle of 100 degrees, which provides ample time to stop and avoid a potential die crash. In this application, emergency stop is the best choice. After selecting emergency stop, we now need to program our ready window. The ready window is the portion of the stroke where we look for the green sensor to change state. This is where the event we are monitoring occurs. The green sensor being a cyclic event, we expect the sensor to change state or activate once a stroke when the event we are monitoring occurs. We also expect this event to occur during a predictable portion of the stroke, our ready signal. What differentiates the green sensors available to program, green quick check, green constant, and green flex, is the relationship between the sensor actuation and the ready window. For a standard green sensor input to be satisfied, two criteria must be met. The sensor must turn on sometime during the ready window, and the sensor must turn off sometime during the stroke. We do monitor that the sensor is not shorted out. A green sensor is allowed to turn on and off multiple times during the ready window. The sensor may turn on and off It can also turn on anytime outside of the ready window. As long as the sensor activates during the ready window and turns off sometime outside the ready window, the criteria for the green sensor is met. A green sensor fault will be generated if the sensor does not activate during the ready window. If the sensor is on or shorted for one entire stroke, we also give a sensor fault. In our application, we expect to see the part ejection sometime between 270 degrees and 350 degrees. We'll turn our angle on at 270 to start looking for the sensor. And we'll shut it off at 350. If the part is not ejected out, by 350 degrees, this is the point in the stroke where we will generate our emergency stop. Masking is a special feature offered for green sensor applications where the event being monitored does not occur every stroke, but does occur in a regular sequence such as a gagging application, zigzag feeds. Please see our masking video for programming of these applications. Thank you for your time, and we encourage you to visit the Production Resources Incorporated Learning Center for additional training videos and application knowledge. Here are examples of the green sensors being satisfied and when faults will be occurred. If you look at the OK on the left-hand side of the screen, the sensor is on during the ready window. We can also come on after the ready window. As long as that sensor comes on sometime during the ready window, we consider that to be an OK condition. The sensor can turn on and off multiple times during the ready window, and it's also allowed to turn on and off outside the ready window. We will give faults, and the press will stop if the sensor is shorted out and is on for an entire stroke. The decision to make this stop is at the beginning of the ready window. We also generate a stop if the sensor does not come on during the ready window. This fault will be generated at the end of the ready window. That's why it's critical to make sure where you end your ready windows